I like the fact that you're all in the middle. So what if I did an Andy Reid? How about them? Right, boy, we're excited here. All right. Now, let's see. Any KU fans here at all, or not? K-State. Well, I got one maybe. One. They won last. They won last night. What? Well, our starting guard, what's his name? You know, has been around for 6 years. He's working on his doctoral degree in phys ed or something. I don't know. So anyway, he was out, so he didn't play at all. Hurt his ankle. Come on in. Come on in. Yeah, it's those that have the most money will win the most. Um, about a year ago, when we came and you attended, most of you, the 6-week course, I was working with you. Remember I don't know what the title was, but was it Bill Collins? Does that ring a bell? Anybody? Yeah, Bill. Yeah. He was here, and he was going to be my red hot spark plug to help me get through getting all set up, and where do we do this, and can we put the equipment over there, and all of that. And he left for Eudora or whatever, and Roy Fain jumped in and became his replacement. And so I got to know Roy a little bit, and we visited and so on, and he really helped me cut a lot of jungle, because I had never been in this building before, and it was very helpful. And I asked Roy if he would pray this evening to start our time together. And he said he would.
Okay, let's pray. Father, we thank you so much for your presence in this place. God, we thank you for your love, your grace, your mercy, and your forgiveness. God, I ask that you minister to us as we're ministered to, and that your anointing would be on every word that is said and heard in this place. In Jesus' name, amen.
If you were here last week, you heard Dave talk about climate change at the end. Remember that? Talk about climate change? And he, in the 1,000 words that he spoke on climate change, he mentioned 2 professors, by not giving you their name or their positions, that were saying climate change is a hoax, basically. So last time we were here, or the last time we did this, I found those two professors, and I wanted to just read 3 short paragraphs. They're big print, so that you'll know that what Dave was sharing with you last week, you can believe him, but I want you to also know that there's a little more support for him as a result of what he shared. So it starts out, this is an article from last year, year before. 2 prominent climate scientists have taken on the Environmental Protection Agency, that's EPA, their new rules to cut CO2 emissions in electricity generation, arguing in testimony that the regulations will be disastrous for our country for no scientifically justifiable reason. Citing extensive data to support their case, William Happer, Professor Emeritus in Physics at Princeton University, and Richard Lindzen, Professor Emeritus of Atmospheric Science at Massachusetts Institute of Technology, MIT, argued that the claims used by the EPA to justify the new regulations are not based on scientific facts, but rather political opinions and speculative models that have consistently proven to be wrong. Now, for those of you that aren't in academia, especially at the university level, when it says that these 2 guys are professors emeritus, that means that they're retired, but they're still active in the scientific community, and they were considered like excellent professors. They don't just give out, everybody that retires from being a professor at a university doesn't get the title emeritus. So it's a very special title. They were probably in charge of a whole group of physicists or whatever. So last paragraph here. The unscientific, this is what they say to I think they're sharing this with the legislature. The unscientific methods of analysis relying on things like consensus, peer review, government opinion, models that do not work, cherry-picking data, and omitting voluminous contradictory data is commonly employed in these studies that are being promoted and by the EPA in the proposed rule. That's what they state. So you got two really eminent, one from Princeton and one from MIT, Dave graduated from MIT, that are saying that this is all pretty much a hoax. Let me, if I can go just, can I read just a little more? I don't want to bore you, but they said about energy, said, I was funding a lot of this work. That's not right. Here, I'm sorry. It's on the back, this is front back. None of the studies provide scientific knowledge, and thus none provides any scientific support for the proposed rule. That's that EPA ruling. All of the models that predict catastrophic global warming fail the key test of the scientific method. Dan talked to you about the scientific method earlier. And they say they grossly overpredict the warming versus actual data, they stated. The scientific method proves there is no risk that fossil fuels and carbon dioxide will cause catastrophic warming and extreme weather. No data that will support that. So what Dave was sharing last week was true, is true, and you've got verifiable information from two really excellent people. Everybody's just, the reason they're doing this is they're retired. If you say these things as a professor at KU, and you're not going to have a job for very long, or you won't get any government funding to keep your little, whatever your little niche is, going. So there's a lot of pressure on these professors not to really tell you the truth, and sometimes they probably know what they're sharing is really not accurate. Okay, you ready to go, Dave? This is going to be a little science for you. I don't want to steal your thunder, but I will, because you got a lot of thunder. This issue right here that we're going to talk about for the next 20 or 30 minutes is one of the issues that the science people, the natural science people, un-Bible science people use, and it's the most probably common one that they cite. They'll say the speed of light's 186,000 miles per second. That comes in opposition to a young Earth creation. So it's important that you kind of grasp what Dave is going to share with you, because he again is going to take that down. And we non-science people just need to know that there's data out there that doesn't support what the scientists out here are saying. All right, I'm sorry. Did I do your introduction?
Yeah, can you hear me okay? Okay.
All right, go get him.
I'm going to steal some thunder from Senator John Kennedy from Louisiana, and he had it in a testimony, in an interview, and I'm going to share it with you. It has to do with this global warming. He said that Noah claimed that there was going to be dramatic climate change. He said, but the deniers and the fact checkers perished in the flood. And the guy was interviewing just sat there and didn't know anything. And I thought, well, today, these radical climate change people that we have are saying Mother Nature is going to create a catastrophe in the weather. The only thing is, the deniers and the fact checkers, I don't think are in danger of perishing. That's us. So times have changed. There's times for climate change, like in the days of Noah, but there are none today. There's like this guy that was a professor, aside from MIT, he was the head of the department of what they call meteorology. That's climate change. We have a class that Okay. Is that better? Oh, I got it. You want to take it out from the collar?
Oh, yeah, well, you put that on there, I didn't. Hang on. How about on this side? Huh, I don't know, try that.
Okay, that sounds good.
Thumbs up back there.
Okay, good. So I'm giving.
Part of the reason that he's having not quite as loud as he usually is what happened on Monday.
Oh yeah, I had molar pulled out, and I was talking to Mike Fry in the back for lunch, and I said, or for dinner tonight, and I said, Mike, I said, sometimes talking to you is like pulling teeth, and I said, I already had one this week.
That was I thought it was nice that you called it a molar because a lot of people call them wisdom teeth. Wouldn't want you to get rid of all your wisdom.
Right. Okay. No. It was a backhanded compliment, you say. What we're going to talk, one of the strongest arguments that is used in science against a creationist position that the universe is only like less than 8,000 years old. They say it's 13.7. Now they're going to have to jump up to who knows what figure, since that James Webb telescope can see so much further than the Hubble. And now you won't hear in the scientific community anyone pushing the Big Bang. There's no way to explain the thing, because we're seeing light so far out there sent to us, and it had to travel. To give you an idea, the nearest star using Einstein's speed is 4 years. But his speed isn't correct, and we're going to see that tonight. To travel out to the probe, Voyager 1, it was sent out in 1972, I think it was, it takes 29 hours to travel out there. To go to Pluto, it only takes 4.5 hours for a signal to go or light to travel. Radio signals and everything travel at the same speed of light, so what we're seeing out there, they would say, using Einstein's speed, that we're looking at a universe under Hubble. The furthest galaxies out there were 13.7 billion light years out. You should measure distances in light years. It should be measured in kilometers, because the speed of light's a variable, and that's what we're going to get into tonight. There's questions. Does a distant starlight prove deep space? That's the question we're going to raise tonight. Is the speed of light a constant? 86,000 miles per second. That means it would take 1.5 minutes to travel to the moon. And at that speed, you could go around the earth, 7 times in 1 second? So that's a pretty high speed. But what they don't understand is it's not constant, and the universe is enormous. What about the Doppler effect from distant objects? In other words, the light, they say, as you get further out and further out, they say there's a Doppler effect, and we talked a little bit about that at one point. It's like a truck, you hear the sound beep as it goes past you. Well, the Doppler effect is it's moving towards you, but as it's moving away, the frequency drops, and light does the same thing. And that's what the red shift is, a downshift in the frequency and the energy of the light. So they're looking at these things, and they say, well, the further out it gets, and they say further because it's getting smaller and smaller, the galaxies, then it's called, there's a constant. I forget what it is. But the further out it goes, then the more redshift you get. The only trouble with that is theirs is based on velocities. So as you move further and further out, it's moving away from us, so we get a redshift. They say the further it's going out, the more redshift. Well, they say it's expanding out. It's accelerating away. Well, that takes anti-gravity. So then they come up with the dark matter and dark energy, as we talked about last time. And you say, dark matter and dark energy? Making up 96% of the universe? Where'd you come up with this? That's against all the laws. What I'm saying is this, they violate all the laws. Well, this is the question, is that redshift? No. The further light travels, it loses energy. So the frequency will go down. Frequency in light. For instance, infrared, red light, is a low frequency. But ultraviolet's a high frequency. That's why ultraviolet's dangerous to you, but infrared is just warm to you. But you get out in the sun and you'll get burnt with ultraviolet, but you won't get burnt with infrared because it doesn't have nearly as much energy. So the Doppler effect, as light's traveling along, it's losing energy as it goes, and its frequency goes down. And so that's why you have that effect. It's not because it's moving away from us or even accelerating away from us. They would say, well, there's more redshift because it's accelerating away. Anti-gravity is pushing the universe apart. These are all things. You see what I'm saying? Their whole theory is violating Newton's law. It's by not violating all the laws that we have in science. I used to believe it, so I include myself in this foolishness at one time. This is just not true. You have to break in gravity, anti-gravity. All these things are made up to patch up a system that they're trying to explain the universe without God. They don't want to say it as a creation. They want to give a naturalistic explanation, and they break all the laws of nature. Einstein's theory of relativity, in that there's two forms of Einstein's theories. There's special relativity, which was done in 1915, called special relativity. It assumes there's no acceleration. It's frames of reference where there's no acceleration and no gravity. Of course, no such thing exists in the universe. There's gravity every place. So, but in that law of special relativity, the second postulate of that is the speed of light's constant. And so what happens is you get space all warped. If you set it, the speed of light's a distance divided by time. Well, to keep that constant, you got to bend time and space. That's why they have light time slowing down as you approach the speed of light. Well, you say, approach the speed of light with respect to what? There's no stake out in the universe that you can measure anything off of, velocities. So it all becomes somewhat insane trying to work at it. You just warp space. And space is then in general relativity is that space is warped around gravitational frames. They don't believe that gravity, electromagnetism, or anything can work at a distance. They have what they call virtual particles. They go out and transfer. Somehow my body creates gravitons. And they go out and they affect the earth. And all of us put out gravitons. And then they disappear when they get there. You say, what? Where'd that come from? And they don't believe that electromagnetic fields, magnetic fields, electrical fields don't exist. Those are transmitted by photons. Again, the photon is created, it's supposed to be electromagnetic and it's supposed to be light. But as we're going to see, light cannot be a particle, like they say, and it can't be a wave. You know why? What happens when you push a particle or any mass up toward the speed of light? It becomes infinite. That's the whole process of the super colliders, as you pull these protons up there to the speed of light, and they hit like a Mack truck, and they run them together and try and break them apart. That's what the whole principle is. Any object, as it approaches the speed of light, and then that's another question, approaches the speed of light with respect to what? They never tell you. But as you approach the speed of light in a cyclotron or an atom smasher or whatever you want to call these things, they get them spinning around. They run these because they're charges, protons are, so you can run a field out in front of them, just get them going up near the speed of light. Then you run two of them into each other and you see what pieces come out. Well, that's the whole principle. In other words, a piece of matter can never travel at the speed of light. Its mass would become infinite. The trouble with light is it never travels slower than the speed of light. So you have the speed of light between matter and energy, and you can't go from one to the other. So E equals mc squared is wrong in the sense that it's not matter converting to energy or energy into matter. These are postulates of Einstein's relativity, but the one of general relativity says that the space is warped bound things. In other words, the moon's following here. I don't know if you remember going to, it was Wendy's, I think it was, where you went in and you dropped a coin in there and that coin just went around this funnel, slowly loses energy and then falls in the bottom. They think gravity's like that there's no force of gravity from the Earth pulling on the moon. It's traveling in warp space around this circle with no force pulling on it. At the right speed, if it loses speed, it'd come in. If it had too much speed, it'd go out the warp space. And you say, well, where did the energy come from to warp space? I mean, it seems crazy to you. You mean gravity doesn't work at a distance? Doesn't have fields and forces that it exerts? No. All this is done by what they've called virtual particles. They don't tell you most of this stuff, but they teach it. And you sit there and your mind is just kind of turning and saying, what are we talking about? What are we talking about? Trying to make sense of it. And they say, it's counterintuitive. I heard that all the time in physics. Counterintuitive. Counterintuitive. You know what counterintuitive means? Doesn't make sense. That's a technical way for saying these two things that are contradictory, you're putting them together. And so all of this is taught and believed, but no, there are powers of gravity, forces. Electromagnetism exerts forces. A magnet, when I put a magnet under a piece of paper and I put filings and move it there, it's not gluons. Photons going through there and moving those particles. There's a field there. So what you have in Einstein relativity, this is just one aspect of it. This has to do with special relativity. The speed of light is constant. And that's why they go out and say, oh, it's so many light years away. Our galaxies is 100 light years across the Milky Way. That's what at Einstein's speed it would take to travel across there. But this work that I'm going to talk about to you was done 40 years by Maxwell before Einstein ever came up with his theories. Maxwell was the master of electromagnetism, and light is electromagnetic field. It's traveling this way, and it's a magnetic field, electrical field and magnetic field going like this. We had this professor there. He was explaining to us, a little guy, that he could teach you Hans Mueller. And it's the Geiger-Mueller counter. That's how old he is. And he was there, and he's going across, he's a little guy with a heavy German accent, and going across the room showing you how light waves were going across there. And he was so good in one class, he could explain to you all of classical physics. And I drew his card. They had a main lecture, and they had what we call tutorials with 20 guys in it. I drew his card. The computer gave me, everyone went in there one day, how much you want for that card? How much you want for that card? Everyone wanted to get in his class. But he would take problems that the main professor made a mistake on this. 2 exams. It took 7 equations and 7 unknowns to solve, and it's supposed to be only no more than 3 on a problem. And so then we walk in there, and Hans Mueller, he hadn't even looked at the problems, and we're going through this tutorial. He's explaining how the answers in this one. Guy says, oh, Professor Mueller, how do you solve this first problem here? And so they can see him starting to wander into this problem, and then all of a sudden, he takes a turn. It was obvious, and he solves it with 2 equations and 2 unknowns, just in less than 5 minutes solved the problem. He says, what are the answers? He says, Professor, that's the answer. This guy says, but Professor so-and-so that's running this course, it took him 7 equations and 7 unknowns. He says, I don't know why. This is quite a simple problem. And we had a bunch of geeks in my class. At MIT, we collected a lot of them. And after a few times like that, they're always trying to pick the professors apart like they knew everything. It got so Professor Mueller says, no one said anything. Because he was working things very simple. He made some very simple hash out of things that were very difficult for us. And so what happened is Maxwell did his 4 equations from which we get all of our electromagnetism from. And his were originally 20 equations. There are a guy named Heaviside. This will help you too. Heaviside didn't have any formal education. And he reduced Maxwell's equations to 4. It's just like Faraday. You know Faraday, who was the master of electricity before Maxwell? Faraday didn't have formal education. And he was the master that laid the groundwork for, Faraday laid the groundwork for Maxwell's coming after him. And he was the one that told Maxwell, he says, I think light is electromagnetic. And Faraday and Maxwell asked Faraday, why do you think that? Because Faraday was a master experimentalist. He says, because I can put a gravitational field and it'll change the course of light. He said, and we have a principle in physics. If one thing is, say, electromagnetism, it interacts with something that produces another effect, then the middle thing is electromagnetic. If it's a magnet in this case, then the other has to be electromagnetic too. Physical things. One physical thing reacts and produces another physical thing, then you know that the middle thing is a mechanical thing. Well, anyway, coming back to this, is the speed of light constant everywhere? Maxwell's derivation was done, like I said, in the 1860s. It's the impact of magnetic fields on a transport medium. Einstein said that light has no medium. And that's crazy. It has to have a medium. This is from the first law of conservation of energy. They go out, the electric field and the magnetic field are together. They go out to maximums, then they come together when they're reversing fields to 0 point energy, and then they go to maximums again. You say at the 0 point, where did the energy go? It's got to be conserved. In circuits, sometimes you can change back between magnetic fields and electrical fields and oscillating circuits. But this isn't the case. They're in phase with each other. And automatically you know it's exchanging energy with a medium. It's just like a wave on the sea. What's its exchanging energy? It's gravitational energy with the water. You hit a rod on the end, a steel rod, and sound waves will go down through it. It's interacting what? With the steel. Every wave is oscillating, interacts with a medium, and light's no exception. And he says it doesn't because he wanted it to be constant throughout the universe. Here on the earth, yes, light has the same speed because we're in the same gravitational field. But as you go up, it picks up speed. You know these GPS units you have? They're dependent upon making contacts. You want to get down to a centimeter accuracy with something traveling at 186,000 miles per second, 300,000 kilometers per second. You've got to have about 6 or 7 satellites to get a good point. Why? If the speed of light was constant, you wouldn't. Just need 1. Or just 2 to triangulate it. The reason is the speed of light changes as it goes up and moves away from the earth. It picks up speed. The weaker the gravitational field, the faster the speed, as we're going to see. Observations of light variability. In water, diamonds, and celestial bodies. A diamond, do you know why it sparkles? You know what the speed of light in a diamond is? It's 1/2 of what it is in the air. It's 90,000 miles per second, a diamond. whereas in the air, it's 186,000. And what happens, it reflects inside. It refracts. And so something changes mediums, it changes speeds. If you get on the bottom of a swimming pool, look up, you can see things out to a certain point and then it turns silver. Why? Because the speed of light in water is slower than it is in air. Why do your glasses work? Why do your glasses work? It's because the speed of light's changing and it bends at the surface and you can focus it. I can set up a big lens and focus it and burn things, concentrate it, because it changes speed, and the speed inside of your glasses is slower than the air. These are things that everyone knows about. The speed of light, they say, well, in a vacuum. But you know what, in a vacuum? We're going to see. Light has a different speed in different vacuums, put upon the gravitational field they're in. So we come back to the thing, does the constant starlight prove deep space? No. Is light a constant? No. We're going to see why. What does the red Doppler shift of object? Does it depend upon the speed of light? No. This is the equation that Maxwell came up with in 1860s. That's where your mind goes blank at first. It's going to become... No, but you'll understand it pretty quickly. It's a lot simpler. You see that? You ever heard of E equals mc squared? What's the c squared? It's the speed of light squared, okay? E, energy, is equal to the mass times the velocity squared. That's E equals mc squared. This is c squared. Now look at this. These two things, one of them's called, they're electromagnetic parameters of the medium that it's traveled through, whether it's a diamond or water or anything else. This is the electric one. This is the magnetic one. Those measure the strength of the medium they're traveling through. Like in the case of a diamond here, what do you think those are? You think they're strong or weak in a diamond? Strong. What's going to happen if this is on the denominator? If this becomes very strong, what happens to that? It's going to go down. Say, hey, if that went to 0, what would that be? 0? What's anything divided by 0? No, it's infinity. It's 0 on the top. That's where you get 0. But if you put 0 on the bottom, the values go through the ceiling. So what happens? If you get in a diamond, you're in the air, okay, air's got a certain one. You go into a diamond that's stronger than the air, and this is going to go down. If this approaches nearly 0 in deep space, what's going to happen to your speed of light? It'll approach infinite speeds. Well, where do these things come from? They only come from the electromagnetic fields, electrons and protons in matter. They've known this since Maxwell. You can't get magnetism without matter. You can't get magnetic fields. You can't get electrical fields. They don't exist in 0 matter. So in water, this goes down. This becomes stronger, so the speed of light goes down. Air is lighter, so it goes up. So what we're dealing with is the constant this, Einstein was, so this comes out to your speed of light squared, your 186,000 miles per second squared. Well, that's that equation, but it only comes from matter. What happens when you move away from matter? Why would a vacuum here on the earth? There's no matter inside of that. Why should it have an electromagnetic field? It's from everything around it. All of us have fields. We're made out of electrons and protons. We all have electrical fields around us. So if they try and travel through you, like X-rays can travel through you, they'll lose speed. You see what I'm saying? The stronger the field, the slower the speed. The weaker the field, the higher the speed. Well, as you move away from celestial bodies, you're moving away from these electromagnetic fields in matter, electrons and protons with their fields. You move away from them, well, what happens? Bottom approaches zero, and your speed of light will approach infinite values. You can't, it's not infinite because you can't, there's no place that you don't have gravity. There's no place that you don't have the effects of matter. So, you'll always be less than infinite speeds for light. But in deep space, you're going to do that. So what does that mean? If we look at it, it means that when we send a signal out to Pluto, you know, the probes that went out to Pluto, and you send the Pioneer, send a signal out to it, and it immediately sends a signal back. What's going to happen? The speed of light is going to pick up, and then it'll slow down again as it comes toward us. So your lapse time will be what? Shorter, Einstein's speed. So they have what they call a Pioneer anomaly. They send out signals. The Pioneer had them send them back. And we knew where the probe was, the Pioneer was, from Newton's laws and everything. Well, it always appeared that it was closer. Because why? The signal was traveling faster than Einstein's speed. Now these ones that are way out there, they'll send them out. It takes 29 hours to send the signal out. And when it comes back, and it appears to be closer from the signal because the speed of light's not constant. These are ways that we've been able to experiment to find out if this is really true. You have two ways to determine what your speed of light is. And that's even with the delay that the probe takes to get the signal, go through its electronics, and send you the signal back. So it's even faster than that signal time that we get. Well, elapsed time on what's 29 doubled is 58 hours to go out and come back with the signal. So what you have here is, yeah, if Einstein's speed was true, sure, we're looking at a universe that's probably 13.7 billion years old. That's how long it would take to travel out to those most distant galaxies or not. But if Maxwell's correct, that light we're seeing from those most distant galaxies is probably only a few years old at most, because it's booking it. Because it's not only in interstellar space, in a galaxy, it's in intergalactic space. And there's huge spaces between them. And so that denominator is very close to zero. Your speed of light's very close to infinity, traveling from those most distant galaxies to us. And you know why we know these laws are true? The light coming from those distant galaxies is the same light as we have here. In fact, we can take that light. Every element gives off a certain spectrum of frequencies. We can run it through a spectrometer, split it out, and we can tell what's on the elements that are on those distant stars or galaxies. You can tell it's almost all hydrogen and helium. Occasionally you get a few other heavier elements, but very few. So we know what they're composed of. We know what all the stars are made of just by the light we get. In other words, the laws of science are true throughout the universe. It's called, in physics, the cosmological principle. All the laws that we see here on the earth are true throughout the universe. And what you have is time is not warped. Space is not warped. You can't slow down time. You don't even have a reference frame to slow it down from. You know, it has to be gravitational frames that you work with. That's another issue. But what I'm saying here is we're looking in a universe that is enormous. You know how long it took that Voyager 1 to get out there? 50 years nearly. The speed of light only takes 29 hours to travel out to it. But it's taken 50 years. You know how fast it's going? 38,000 miles an hour. It's taken 50 years. And it's just recently got out of the gravitational field of the sun. So, and that's one star. What we're looking at is a universe, as we've talked about, of 10 with 24 zeros behind it of stars that we can see, or galaxies, stars. There's about 10 trillion galaxies. That was based on Hubble, each with about 100 billion stars. Now we're learning that the universe is much bigger than we thought with the Webb Space Telescope. It's about 2 or 3 times as far out there. And so it killed the Big Bang Theory. It didn't blow out from anything. And it's not, if gravity was true, it would be slowing down. It'd be pulling back gravity. It'd be decelerating all these stars and everything. So this thing's dead. What I'm saying, a lot of you don't understand some of the physics, but I'm telling you, you read the scriptures, you'll be a lot smarter than these other people. You'll realize that the universe is only about a little over 8,000 years. Scriptures tell us the truth. And the science stuff is not science. It's make-believe. It's not based on real science. The people that promote these things, they tried to put probes onto Mars. Did they succeed? No, they crash them. Because they assume the speed of light's constant. They send a signal, and it's got to be executed when it arrives at a very particular point to go in orbit. No, it doesn't. It crashed. So now you have to preload your signals out to the probe, and it knows where it is from radar and from Newton's law. And when it gets to those coordinates, then it executes it. But if you assume that it's going to arrive, you're just in time. No, it's never in time. It's always behind time. It's always ahead of time. So it executes a signal before it's supposed to. And it crashes. They crashed in 4 of them. Wasted hundreds of millions of dollars in probes initially. Now they've gone back to classical physics, and they can land them on Mars. They can land them at any place they want to, but time is uniform. It doesn't change throughout the whole universe. Once you set a time in the universe, everything is synchronous. On Mars, on distant galaxies, whatever, the time is passing at the same rate. The Lord set up the universe to run this way. Space is not warped. It's linear in every direction. These are make-believe stuff, and they do not work when you try to use them in celestial physics. So anyway, what we're saying is we're coming back to the same thing that the scriptures tell us the truth. The universe was created, the whole universe, less than 8,000 years ago. At the same time that man was created in the same week. All the stars were created at the same time. And that's what you have. And when it comes to a culmination, when the Lord returns, and then at the end of the millennium, he'll destroy, he'll let go. It says even the elements in 2 Peter and Jude, he'll release. Someone's holding together the very elements that we're made out of, the atoms we're made out of. Someone's holding them together, and they talk about the strong force, strong nuclear force, and I said, what is that? Where's it coming from? How come we can't test for it? Things. We know something's holding the atoms together because when you have all those protons together pushing against each other, the whole thing should blow apart. Every atom in our body should blow itself apart. We don't know what's holding it together. Yeah, we do know. It says like in Colossians, in him all things consist. It means it's a word to hold together. And when he releases it, like in 2 Peter, it says all the elements will burn with fervent heat. In other words, and then he creates a new heavens and new earth because the old one, it says, has passed away. So we're living on borrowed time. Talk about catastrophes. Noah was just getting started.
So, let's see. Okay, now you correct me, okay?
Yes, sir.
Okay. So, as a non-science person, I think what I heard you say is, just to be fair, that Einstein's theory, part of it, that speed of light here on Earth, and around the Earth up a ways is correct.
It's constant, yes.
It's constant, 186,000 miles per
Per
second.
second.
Okay, so he was correct in that regard. But when you start moving on out in space where things get separated, and the reason it's 186,000 miles per second is because the Earth is giving off these magnetic fields that keep it at that.
Yeah,
right?
all the matter around here creates electromagnetic field that we're walking through.
Yeah, okay. And we're even helping.
Oh, yeah,
We're all giving off this.
We're part of the system.
But when we send a probe out and it gets away from the Earth, and if there aren't any other planets or anything, then the fields are not as strong on that light.
Right.
So that means it speeds up.
Right.
But then if it comes up next to a bunch of planets, a cluster out there that give off, because of
Fields.
matter and energy, gives off more fields, electromagnetic, then it'll slow down for a while.
Right.
And then when it passes through them, it turns into like just a lot of emptiness out there for a while.
Yeah.
It'll speed up again.
Yeah.
So it's going,
The fields that we have, even of our sun, go out into infinity, really.
yeah.
But they're very weak out there. But why ours goes out so far, and the speed of light's decently constant in our solar system, is the sun represents 99.95% of the matter in our solar system. So its field goes out quite a ways, electrons and protons in it. But once you get out beyond that, into empty space, interstellar space between stars, you're right.
It's
you
buffet.
get into intergalactic space, and it's just a vapor. It's not vapor out there.
Comments or questions before we take a break? All right, my colleague, or my,
You mean, well, some of the laws are established from the scriptures because we live in a society, a Judeo-Christian society, so we know what murder is and everything. We even know what sexes are, everything. But we know that races don't exist. We're all the same race. We're all humankind. So we know a lot of those things, and they've integrated those into the laws. But the trouble is they're throwing away these laws. The woke people, where you got the sex is people can think whatever they want to be today, and they can change those things. They can change. I don't know how they change their DNA. They got 50 trillion cells in there with everything typed. This still that these professors are saying, and these were the best in their fields from Princeton and from MIT. These were the best in the climate, meteorology. They were the best business. And they're saying there's no scientific basis for all these. These are political decisions trying to cut back on CO2 emissions. CO2 is almost non-existent in the atmosphere. It's 1/25 of 1%. And all life depends upon it. That doesn't affect anything. It's water's the name of the game. Our weather is all related to water, and also these decomposition of atoms inside the planets and the Earth that give off heat as they decay. That's where our weather and the sun giving off its energy affect our weather. But and water has a very high absorption. CO2 isn't even in the game. And the water in the atmosphere today, it's what, 1 million times more abundant than CO2? And yet it has a greater absorption. If you get a lot of clouds, then the temperatures it's trapped. You do get some greenhouse effect from clouds. It holds the moisture and traps the radiation. CO2 doesn't trap anything. It's what we call, you have to do a level of what do we call that in the back of the envelope, where you do an estimation based on what you know, and it doesn't even show up on the back of the envelope calculation.
okay, we got a comment or question here?
Just when you were talking about warps in space, all I think it was science fiction.
Right? I hate to admit it, but I was a big science fiction guy, but but the science fiction that we had back in the 60s, 50s and 60s was based on the laws of science. And that deals trips to Mars and things like that were all based on that. These are not based on, or these are more of Masters of the Universe type of stuff, fantasies that are, and you know, Spider-Man and you know, all these, the Glob and whatever they are. Those aren't even people.
The Glob. That's a new one.
Yeah. Yeah. Well, no, they were close enough at that time that even as an unbeliever, a lot of the things that were promoted in science were pretty close to real thing. And since the 60s, they've started to make these dramatic turns. And it wasn't even brought up in my classes. We were taught real physics, MIT. That's what killed my whole deal of evolution and all this stuff, because we were taught those laws, and then I got in a heated argument. This is the first year I went to seminary. I was an evolutionist, and this guy had gone from Cornell and was a scientific background. We got in a shouting contest in the bookstore. A guy named Jody Dillos, and he says, and I believed in evolution. I was telling him, he says, how do you put it together with the second law? I said, that's easy. So I went back and got another guy from MIT. We couldn't even get one protein molecule anywhere in the whole universe, the probability of it just even forming in 20 billion years. Did I tell you that my deal going back to the professor? Yeah. And so my world was crumbling, but it's all based on the science that I had to face up to. This science, what they were teaching isn't science about cosmology, origin. Yeah. Origins, when they talk about origins, none of it's science. Either in biological realm or in the physical realm. This is all make-believe. It's violations, as we say, this Big Bang is a violation of almost every physical law we have. I'm going to go back.
Okay, now, the article, I found 6 sets of these, so they're up here. If you're really into what these guys were saying, I think there's more information. And then if there's more of you that would like a copy, I can bring more next week. When you come back, one of the things that we are asked a lot of times that we don't have time for are testimonies. And so I've asked Ward, Dr. Ward over there, if when we come back, if he shares testimony with you, take a few minutes, and then Dave's going to talk to you more about the Bible and how we should be behaving as in relationship to God, in relationship to our country, how we should be functioning. What about our churches and how they should be functioning, families, couples in marriage, kids, that kind of thing, kind of real solid stuff. That this other, if you're like me, my head starts spinning when and I've seen this 25 times, and when he throws an equation up, there's something in my mind that just my mind doesn't work like those equations. And so anyway, so let's take a little 10 or 15 minute break and come back, and it'll be a good time. Hear a testimony and